Hi everyone. Today we're going to be simplifying rational expressions. Your essential question for today's notes is, what does it mean to make an expression undefined? The rational expression definition is a rational expression is a ratio of two polynomial expressions. We're going to write down all the steps first. So to simplify a rational expression, step 1, you're going to factor everything that can be factored. Step 2, you're going to simplify the monomials. You're going to use your exponent rules when you're doing this. Number 3, you're going to eliminate common binomials. Number 4, you're going to list values that make the expression undefined. So for our first example, this is actually a monomial. So you can see that we just have one term up top, one term on bottom. So that means that we're just going to be using our exponent rules. So in order to go through, just look at the numbers first, 14 and 20. What has in common with both? What's a number that's common in both of those? Well, 2. So if I divide 20 by 2, I have a 10. If I divide 14 by 2, I have a 7. Now we're going to use our exponent rules for x to the 6 divided by x squared. Remember that you subtract the exponents when you're dividing, same bases. So 6 minus 2 is 4, and we have more on top than we do on the bottom. So I have x to the 4th on top. So this is actually my simplified rational expression. The last step that we have to do, we have to make sure that we state what the x is not allowed to equal in order to make that the denominator become 0. So we don't want that actually happening. So if I were to plug in so that you can actually set this equal to 0 again, to see what values, if we divide by 14, both sides, we get x squared equals, remember 0 divided by a number is actually 0. To get rid of that square root, the squared, you're going to square root both sides, ending up being reciprocal, so those cancel each other out, and the square root of 0 is 0. So our x cannot equal 0. That's because if we plug in 0 back in for that x squared, so it'd be 0 squared, which is 0. 0 times 14 would get us 0. So this is our final solution, these two right here. 10x to the 4th power divided by 7, and then x is not able to equal 0. For our next example, we actually see that we have two binomials. Remember that your terms get separated by those subtraction signs. So that means that we have a binomial on top and a binomial on the bottom. So we're going to go through and we're going to actually have to factor this stuff because we don't just have a monomial. So I'm going to just take the top of the equation first. If I just focus on this section first, I'm going to see what number, if we have GCFs, because every time you want to factor, you want to go for GCFs first. So I see that I have the number 6 in common. I don't get to take out a variable because there is no variable for that 36, so I just have 6 and then in parentheses k minus 6. On that denominator now, I'm going to see if there's any things I can factor there, which actually I see that there's no GCFs or anything, so I can't do that. So we've gone through factoring. You're going to cancel out the binomials, which is our step 2, and then we have just 6 left over. Once you guys want to check for your no solutions, we can again see that if we have k minus 6 equal to 0, we add 6 to both sides to get k by itself. So then I get k equals 6. So then that means that k cannot equal 6, or else that will get us a 0, making that expression undefined. So 6 and k cannot equal 6 on that. It's kind of confusing. So since k cannot equal 6, this would be no solution. Now on your homework, you guys may or may not have to be checking for a solution, so you would just be giving me this answer. For our next example, we have a binomial being divided by a trinomial. So on the top, I cannot simplify that, so I'm just going to rewrite the y plus 8 over whatever we're going to factor. So we have our y squared. I see that the coefficient is a 1 on this y squared. So I am going to be able to just go through and do my parentheses in this way. So it multiplies by negative 48 but adds to 2. So I know that 8 times 6 is 48, but I'm trying to see which one has to remain positive in order to keep that positive 2. So the positive 8, and it's going to be a negative 6. So then my factors are y plus 8 and y minus 6. So now we're going to divide out our binomials. So then I'm just left with, be careful because that y minus 6 is on the bottom. So I actually have a 1 divided by y minus 6. So just be careful. It does not just turn into y minus 6. So then once we see how it's a lot easier, instead of setting that denominator equal to 0, it's a lot easier setting this denominator the factored way equal to 0, because then it just looks like we're identifying our zeros, our x-intercepts. So remember when you would do y plus 8 equals 0, y minus 6 equals 0, and then we would end up solving for these to actually see which values would be our x-intercepts. It's the same thing, you guys. We're going to be seeing which values we cannot have y equal on that denominator in order to make it undefined, making that 0. So we can rewrite this and say that this is our final simplified rational expression, but our y cannot equal a negative 8 or a 6. Actually, let's say and. So it cannot equal a negative 8 and a 6. Okay. Our next example, we have a trinomial being divided by a binomial. So again, remember every time you're factoring, you want to take out a GCF first. So I know I have a 2 as my GCF, no variables though, so this is just an r squared minus r and then minus 20. And then now see I have a coefficient of a 1 in front of that, so I am going to get to be able to write my parentheses out here. So what multiplies to negative 20 but adds to a negative 1. So if we go through that, we know it's going to be 5 and 4, and we just have to figure out which one has to be negative again. Well, I actually need to have more negatives than I can positives, so we have r minus 5 and r plus 4. So that all, so let's rewrite this again, because let's take out our GCF as a denominator. This will go on our numerator. GCF of 8r plus 32. I know that 8 goes into it, so I'm going to have 8, and then r plus 32 divided by 8 is 4. Okay, so now we're going to rewrite this expression with my factored form in my numerator. Don't forget this 2 right here, because that was our GCF originally. So we have a 2, and then I'm going to bring those over to here. So r minus 5, and then r plus 4. Oops, r plus 4. And then divide, now bring this guy to the bottom, so 8, and then r plus 4. So now we're going to go through and simplify our fractions. I see I have r plus 4 here, r plus 4 here, and the other thing I can simplify is that 2 over 8. I know that 2 goes into 2 one time, 2 goes into 8 4 times. So my official equation would just be r minus 5 on the numerator, and then we still have that 4 on the denominator. Okay, and then we go back just to see right here in this little denominator right here, we want to make sure that when r equals what, it's going to get me 0. Well, if I just do the opposite of that positive 4, I know if I got negative 4 plus 4 would be 0. 0 times 8 would be 0. So our r cannot equal a negative 4. So this is our entire solution here. Okay, so the next little thing I just want you guys to be careful of, I want you to watch out. So there's this little watch out sign right here. Make sure you write this down, because a minus b is not the same as b minus a. That means you have a negative a and a positive a, or a negative b and a positive b. So we're going to go through and do this problem. So just be careful. I want you guys to watch out for this. So it looks like we don't have any GCFs on my numerator up here, but we do have a difference of 2 squares because I have only 2 terms. And I know that p squared is a perfect square. So I have p, and then I have a minus 7 times 7 is 49. And then since it's a perfect square, I'm going to do a, oops, not 7, sorry, 4. Not 4, but 7. So p minus 7 and p plus 4. And then we have a 7 minus p down here. So this is what I want you guys to watch out for. This is not the same as up here, as one of these. So we got to make sure that we actually take out a negative 1. We're going to factor out a negative 1 out of here because I want to change the values of this. Remember, negative 1 can be a GCF here. So I have p plus 7 still. And then now I have a negative 1 here. That 7 is now going to become a negative 7, which I do have a negative 7 right here. And that negative times a negative has become a positive p. So I do have a positive p right here. Before, I had a positive 7. Okay, great, I had a positive 7 here, but I did not have a negative p right there. So just be careful. So now I'm able to cross these out even though the letters and numbers are reversed. It's okay. And then I have a p plus 7 divided by a -1 still. So I still have all this. So there's two ways that you guys can write this as your final answer. You can have p plus 7 divided by -1, but anytime that you guys have a -1 down there, we're just going to actually distribute that, meaning that that positive p is now going to become a negative p. That positive 7 is going to become a -7. So this is what I want your final answer to actually be. I might give you guys just a half point off if you were to write it like that, because you're just dividing by a -1. We're all capable of doing that at this level of math, I think. So the last part we have to do is just to set this equal to 0. Well, if I just add p to both sides, that means that I have 7 equals p. So that means that 7 cannot equal p, or else I will have a 0 on my denominator of my fraction, making it undefined. For our next example, we have 12a to the third power minus 3a. Awesome. I have a GCF that I can actually take out there. So I have a 3a as my GCF, and I'm left with a 4a squared minus 1. Be careful, because I'm going to be able to factor this guy again. So we're going to keep going through and take out our GCFs first. Our next GCF on the denominator is actually a 6a squared, which means I have a 2a left over plus 1. Be careful that doesn't just go away. Make sure you have that 1 there. Okay, so now I'm going to finish out factoring the rest of my numerator here. The reason why I told you guys I still have more is because I know that this is a difference of squares. Again, I have two terms. 4 is a perfect square, a square is a perfect square, and 1 is a perfect square, and I have that minus sign. So I'm going to go ahead and bring down my GCF. Don't ever forget those. Your perfect square is a 2a minus 1 and a 2a plus 1. So that's my difference of squares. So then I'm going to rewrite my denominator here. That 2a minus 1 that I had, or sorry, plus 1 that I had down here cannot be simplified anymore. So now you have to start crossing out those binomials. 2a plus 1 gets canceled out. This 2a minus 1 is still there. 6 and 3 get to simplify. And then my a's also get to simplify. So we have a 2 left over here. So now just rewrite your numerator, 2a minus 1, and my denominator, which is a 2, and I just have an a. You are not able to cancel these out because this one is attached to this -1. So you don't get to cancel those out. I know everybody wants to try to, you don't get to. Okay, so then I just need to figure out what my denominator is not able to equal. And you want to actually go back to the beginning of the very first part where you factored that denominator. So we're going to do the 6a squared, because these are factors, you're going to set them equal to 0. So 6a squared, basically, just divide by 6. A squared equals 0. Square root, so I get a equals 0. So a cannot equal 0, that's one of them. And then we have to do this with my other factor. So my other factor was that 2a plus 1. And again, you always want to start off with your original value before you start simplifying it. Make sure it's that factored very first value that you're setting equal to 0. Subtract 1 from both sides, I get 2a equals a -1. And then I'm going to divide by 2 from both sides, and I get a that actually is not allowed to equal 1/2 for this equation. So these are our two a values that we are actually not allowed to get. So a equals 0, cannot equal 0, and a cannot equal 1/2. And then this is our final simplified solution. Okay, we have our last two examples here. They're just a little bit harder factoring problems. I just want to make sure you guys remember how to factor when the coefficient is not a 1 in front of that. So we have our 6n squared plus 8n plus 2. Always take out a GCF first. So I have a 2, and then I don't have any n's I can take out, so we have 3n squared plus 4n plus 1. Okay, so this is what I'll be finding my AC method with, or if you use your box method, that's totally fine. So you always do 3 times 1, so which is 3, and then you always put your b term in the denominator, or in the bottom of that diagonal, or cross, whatever it is. So you're trying to figure out what multiplies to 3 but adds to 4. So we got 3 and 1, which is a very nice thing. And then so now we have to actually go through this, and we have to make sure we do our factor by grouping. So we are writing our new b values, bring down the a value, bring down my two new ones, so 3n plus 1n, and then bring down your c term, so there. And then this is going to be our factor by grouping. We have a GCF of a 3n here, and then we have just 1n left over plus 1. And then great, we see that we have an n plus 1 here. Remember, you just bring the plus 1 and n plus 1. We did the factor by grouping correctly. So my n plus 1 is my first GCF, or sorry, my first factor, and then the GCFs of each of those terms is your other factor. So I'm going to go ahead and let's actually finish my denominator here. The denominator has a 2n 2 as my GCF, n squared minus 1, which also, again, hint hint, this is a perfect little difference of squares, so I'm going to take that out as well. So when I go ahead to rewrite this, let's rewrite my numerator. So bring your GCF of 2, then we have n plus 1 times 3n plus 1. And now I'm going to do my denominator, GCF again, bring that down. Difference of squares, we have an n plus 1 and an n minus 1. Okay, go ahead and start eliminating things, and we see that we have a 3n plus 1 and an n minus 1. So 3n plus 1 and an n minus 1. This is our simplified rational expression. Go back to when we simplified right there again. We need to see what n cannot equal in order to make sure that we have everything that we need. So I'm going to erase some of this so you guys can see the problem here. And we're going to go ahead and set that equal to 0. So you have the 2n squared minus 1. And then we have 2 can never actually equal 0, so we just get to completely ignore that one. N squared minus 1 equals n squared minus 1 equals 0. We're going to add 1 to both sides. And then I have n squared equals a positive 1. I'm going to go ahead and take the square root of that. I'm going to cancel those out. Remember, when you take the square root of a number, when we added the square root, it actually becomes a plus and a minus 1. So our n cannot equal a plus or a minus 1. So this is what our n values can equal, and this is our simplified solution.